Hi everyone, I'm Mogul Bobby 2. In this lesson, we'll begin learning Blender's data structures and the core principles of the linking and library overrides workflow. In Blender, all types of objects are essentially made up of data blocks. Let's look at this cube. It is an object itself, with animation data and mesh data attached beneath it, and that mesh is assigned a material. This is the most typical object data structure in Blender. We can think of the top-level object as a container that carries child data blocks such as animation, mesh, and materials. Together, they make up this object, and the container itself can also hold modifiers to process the internal data dynamically without directly changing the original data. One thing to note is that in Blender, armature binding is also implemented through modifiers. This design makes model editing and rigging extremely flexible. You can keep adjusting a model's mesh even after it has already been rigged, or seamlessly swap in another armature. As long as the bone names match, the whole process will not break the existing binding or introduce any extra performance overhead. Data blocks can also be shared across multiple objects. For example, a single mesh data block can be referenced by multiple objects at the same time. I can replace this icosphere's mesh data with the cube's mesh data from earlier. That way, it becomes an instance of that cube. In the Mesh Data Properties tab, we can see that it is now referenced twice. If we enter edit mode and modify one of them, the other one updates as well. At this point, we already have a basic understanding of Blender's data block-based structure. It is precisely because of this design that Blender can provide such powerful and flexible linking and library overrides, and these two features are the core pillars of the entire team collaboration workflow. Next, we'll move into hands-on practice to better understand how they work. In this file, we have prepared a rock model asset. Now, if we want to use it in another blend file, there are two common methods. The first method is append. We open the File menu, choose Append, then find the rock model and append it into the current scene. As you can see, the model has now been fully copied in. The second method is Link. Again, go into the File menu. This time choose Link and bring in the rock model. In the outliner on the right, switch to Blender File View. You can see that this rock model still points to the original asset file. Next, let's do a quick comparison. After saving these two scene files, open the File Manager and check their sizes. You will find that the scene file, imported with append, is almost as large as the original asset file. But the scene file imported with link is only about 1/3 of the former. This leads to a very important conclusion. Link does not copy the original data blocks. It directly reuses the data from the asset file. As the project grows larger and versions keep iterating, Link can bring exponential savings in storage space. However, Link also introduces one issue. When we select this linked rock model, we find that most of its properties are locked and cannot be edited directly. This is where library overrides become useful. We right-click this object and choose Make Library Override. Then you will see that the previously locked transform properties immediately become editable. Now, we can move and scale this rock, and even animate it. Because this rock was brought in through Link, we can also do one more thing. Open its source file, sculpt, and modify the model, then save it. Return to the current scene file. In the outliner on the right, switch to Blender File View. After resyncing, those changes take effect immediately. At the same time, the animation we created for the rock in this remains completely unaffected. If we want to discard, in the current scene, all the changes made to this rock, we simply run clear library, override on it. Then it returns to its fully unmodified state. That is the basic use of linking and library overrides. These topics will be explained and demonstrated in much greater detail in the upcoming production examples. Starting from the next lesson, we will walk through the full pipeline of the HADY project as a whole, and then gradually move into the hands-on breakdown of each stage.